Welcome to Train Signal. You're watching a lesson on network performance and optimization. So in this lesson, we are going to look at a few different ways that we can make sure that the performance of our network, basically stays optimized. But before we get into those specifics, I want to talk to you about some of the reasons why performance and optimization is so important, right? Because you're probably thinking, well, duh, of course we want good performance, right? Why wouldn't we? Right? You want to surf the web, you want it to be fast. Well, I got news for you. There are some actual specific business needs that kind of go beyond just the average human need of, I want everything to run fast. So let's talk about those right here. The first one is uptime. Okay, so we need to make sure that when it comes to business, that we have a certain degree of uptime. And uptime is considered to be a measurement of time that a network is considered to be running. Okay, so you may have heard the term downtime. Okay, so that's when the network's not working. Uptime would be the opposite of that. Different business solutions, right? So that's the other thing you need to keep in mind. It's not just about business as a whole requiring uptime, but different business solutions require different levels of uptime. To give you an example, if you were an e-commerce company where everything about your business had to do with people being able to get to your website, let's say, well, then obviously it's very important that you have a high level of uptime with your website. Whereas if your business was more of a face-to-face, they come into your establishment and you perform some kind of service for them in that fashion, and your website was really nothing more than maybe a form of advertisement, well, then you don't need as much uptime. Obviously, you still want it. You don't want that advertisement to go away, but if it were to go down for a while, you would survive without much difficulty. Whereas an e-commerce company, if the website's down, essentially it's like your building has been shut down. Your whole business, everyone's locked out. They can't get in. No one can buy anything. Okay, so uptime is one real key reason why we need to make sure that we have good performance. And it's not just about optimized performance, but again, uptime and running performance. Now, another one is something called latency sensitivity. And what this has to do with is that certain applications require very quick delivery, which would be low latency, of data in order to be effective. Okay, so if you have applications that need to have things coming very quickly, well, then we need to make sure, in that case, we are talking about real optimized performance. And then the last reason I want to talk to you about is something called high bandwidth applications. We are in a day and age where there are more and more applications that require a lot of bandwidth. Okay, so we need to make sure, since typically we have limited bandwidth, we want to make sure that those applications have the bandwidth that's necessary in order for them to function. All right, so again, the reasons for having good performance is kind of obvious from a human level. We want things and we want them now, right? I want it now. Well, there's also these business reasons that you have to take into consideration. So now that we know that, let's go take a look at some of the specific ways to make this all happen. So the first performance and optimization strategy that I want to talk to you about is quality of service, or QoS. Now, this is a strategy that is used to control the flow of network traffic. And this is done by giving administrators the ability to provide preferential delivery for certain types of applications which need it. So in other words, with QoS, the idea is you can prioritize what types of network traffic get priority over other types, right? Because we have limited quantities of bandwidth. And if we're using up all that bandwidth, there are certain types of traffic that you may want to make sure always go through and go through smoothly, whereas there's other types that maybe don't have to be quite as reliable. A very good example of this might be where you have data traveling along a line, so just your regular everyday data packets, traveling on the same line where you might have some multimedia traffic. Okay, so maybe you're having like video conference calls. Well, you want that multimedia to seem, somewhat seamless, right? You want it to be very reliable. If I was talking to you live right now, you would be very disappointed if No, don't worry. The audio didn't go bad on this particular lesson. That was me giving you an example of really bad audio to the extent that you can't even understand what I'm saying. So if this was being streamed live across the network, we would want to make sure that this data, okay, this multimedia data, was given priority over just regular simple data packets that can get there whenever they get there, and if there's a problem or if a packet gets lost in transmission, it can just retransmit. Okay, so that's the idea behind QoS. Now, something that is related to QoS is there's another term here called traffic shaping. And traffic shaping is pretty much what I was just describing to you. Okay, so I wanted to explain what QoS is, but believe it or not, I was actually defining an additional term for you. Okay, so traffic shaping is how you control the specifics. And where I mentioned different types, I will tell you that very often you will control data not only just from the application, but you can also shape based upon certain users having priority, right? The higher ups in the company always want to make sure that their information, is always flawless. And believe it or not, a really good upper management team will typically tell you that their information tends to have the lowest priority. It's the regular workers who are truly making things happen with their communication to keep business flowing. They're the ones you want to give priority to. And then we can also do things based upon the time of day. Okay, we can understand that during certain times of the day, maybe certain types of traffic have to be a priority, and then during other times of the day, other traffic has to be a priority. Okay, so this is kind of the whole big picture idea behind traffic shaping, which is used by QoS. Now, another strategy that we can use to help optimize our traffic flow and get good performance is something called load balancing. And load balancing is a very general term which defines the use of more than one, and I have here insert variable, okay, because what we're saying here is we could say more than one, and then it depends on what type of device we're talking about, or what type of server we're talking about, or what type of service that we're talking about. Okay, so we're talking about taking two, we'll say, devices that are providing the exact same service and having them act as a single entity. Clients' needs are then satisfied by the first available of whatever this device is. And sometimes you can even have a situation where the client needs are satisfied by both. If we were going to say that there were two of this particular device, sometimes one device can satisfy half the need and the other device can have the other half of the need. Now, the variables that we're plugging in, let me give you some examples. We could be talking about servers, right? Multiple servers acting as a single entity, providing the same service. We could be talking about hard drives, okay, where it could look like it's a single component of storage, but there are multiple physical hard drives which, working together, provide that storage. Or we could be talking about transmission lines, right? Maybe we're talking about literal networking. We have two different transmission lines functioning together, looking like one form of communication, but increasing our bandwidth. Okay, so those are just some examples. So load balancing is a very generic term that relates to all of these different examples. So now the next thing that I'd like to talk to you about is something called fault tolerance. Now I need you to understand what that term means. And the term fault tolerance means simply if there's a fault, well, then it'll be tolerant of it. And the it, we'll talk about what it is in a minute. But what does that mean? If there's a fault, it'll be tolerant of it. It means that if there is a failure of some kind, and typically we're talking about hardware here, but not always. Sometimes we can talk about fault tolerance when it comes to certain services that are being provided. But if there is a failure in that hardware or service or whatever it may be, to say that it's tolerant of it, it means that whatever it is, meaning whatever it is that we're trying to make fault tolerant, it will still continue to perform its function. It will continue running. Now let's talk about that it for a moment, right? Because I keep saying it this, it that. Fault tolerance pretty much covers all aspects of computers and computer networking. Okay, so there's all kinds of areas that you may want to be fault tolerant. I mean, one example would be hard drives, and we're actually going to look at RAID in just a moment, which is fault tolerance for your hard drives. We have power or power supply. We can have more than one power supply or more than one power source. When I say more than one power source, sometimes you'll think of that as like a backup battery, that kind of a thing, right? You lose power from the wall, now you have it from the battery. You have your network adapters, servers. I had mentioned about services. Okay, so that's where your servers will be providing certain services. Our routers, you may need to take different routes, and along with that would be network links. Now, that's not an all-encompassing list, but that's just an example of understanding that fault tolerance. It's in many different places, but the bottom line is, no matter what it is that you're trying to make fault tolerant, it's all about if you had one component or some component fail, things would continue to run. An example of fault tolerance when it comes to hard drives is something called RAID, which stands for Redundant Array of Independent Disks. Now, I will tell you that you may have seen RAID also described as Redundant Array of Inexpensive Disks. Okay, it can be described either way. And the reason we say inexpensive is because the idea is you buy a bunch of small, less expensive hard drives to all work together to create a larger component of storage. Now, there's three main types of RAID, or three main levels of RAID that I'm going to go over with you here, although I will tell you there are more. The first level of RAID is known as RAID 0, and it's called disk striping. I will tell you that this is not fault tolerance. It is a form of load balancing, but it is not fault tolerant. I include it in here because, well, if I'm going to talk about RAID, this is really where it belongs. But here's how disk striping works. You have multiple physical disks, and I will tell you have to have at least two. On the screen I have 3 displayed for you, but you have to have at least 2. And the idea is as you write your data to the hard disk, you write it across, or striping it across, all of the disks. And you do so in 64 kilobyte blocks. Okay, so the first 64K of data is written to the first disk, then the next 64K is written to the next disk, and the next 64K is written to the next disk, and then when you run out of disks, you go back to the first disk, and you just keep striping it. Now, why do we do this? Right? I just told you it's not fault tolerant. Well, the reason is for performance, specifically the read performance. Now, sometimes you can gain performance when it comes to writing, but specifically the read performance is improved, and the reason why is because if you have what's called bus mastering hard disks, which pretty much all hard disks in today's world are, you have the ability to go ahead and read from all the disks simultaneously. So theoretically, you can read the data 3 times faster if you had 3 disks. Okay, so and again, that's not literally 3 times faster because there is some overhead that goes with it, but you're going to get improved performance. So very often you'll see this on a database type, on a database server. If you have a large database, you will use some form of disk striping to improve performance. Now, the next level of RAID is called RAID 1, which stands for disk mirroring. And I will tell you that there's another form of disk mirroring, which is also called disk duplexing. And the difference between just regular disk mirroring and disk duplexing, even though they're both considered to be part of RAID 1, is disk mirroring is where you have multiple physical disks, whereas disk duplexing is where you have each of those disks on its own disk controller. So that way you are putting fault tolerance not just in the possible failure of a disk, but in the failure of a disk controller as well. Now when it comes to RAID 1, or disk mirroring, you use 2 and exactly 2 physical disks. And the idea is simple. Everything that is written to one, there is an identical mirrored copy put on the other. That way, if one of these drives fails, so what? I've still got the other drive. Now, besides the fault-tolerant aspect of RAID 1, I will also tell you that there is a performance benefit because the data, since it's existing on both disks simultaneously, that means that when you're reading the data, these days they've now created RAID 1 controllers that give you the ability to read some of the data from one disk while you read the other half of the data from the other disk simultaneously. Therefore, you again get an improved performance benefit. The next level of RAID I want to talk to you about is where we jump all the way up to RAID 5. Now, you might be thinking to yourself, what happened to RAIDs 2, 3, and 4? Believe it or not, they do exist. They're just not popular. Okay, so that's why I jump up to RAID 5. RAID 5 is called disk striping with parity. This is a fault-tolerant solution, and this is very often considered to be one of the preferred methods when it comes to those database solutions that I mentioned earlier with RAID 0, because not only are you getting the benefits of striping, right, you get those performance benefits, but you now have fault tolerance. And the way that you get fault tolerance is because with RAID 5, you stripe the data across multiple disks. But each time you go across one of those disks, instead of writing data, you're going to write what's called a parity block. Now, I'm not going to go into all the mathematical algorithms and formulas that make up this parity block, but what I will tell you is, and by the way, a quick side note, if you are familiar with some, if you're really good at math, the formula is something called XOR. XOR, or exclusive OR, is the formula that's used to create this parity block. Okay, so that's just if you happen to be real good and you're curious. You could also read all about it. But the idea is that with that parity block, if we were to lose any one hard disk in the stripe, you could use the parity information to replace the missing data that was lost, regardless of which disk that's lost. And again, I know that might sound like, how the heck does that happen? But it's a mathematical formula that does allow this to happen. So RAID 5, disk striping with parity, we stripe the data just like with RAID 0, but this time, each time we pass through the stripe, one of the disks, we don't write data, we write a parity block. And I will tell you that this does require a minimum of 3 disks in order to function. You have to have 2 for data and then a third one for the parity block. Now, before we move on past RAID, I want to tell you that there are other forms of RAID. I mentioned 2, 3, and 4. There's also a RAID 6, which is a form, it's actually, believe it or not, a form of disk striping with parity, but where you can lose any 2 disks instead of just any 1 disk. I will also tell you that there's all kinds of hybrid versions of RAID, where you can have things like RAID 01 or RAID 10, which the difference is where you can have stripes that are mirrored, and then another version you have a bunch of mirrors that are striped. Okay, so you have those. You also have RAID 15 and RAID 51, which is, again, where you have striping with parity that's then mirrored, and then you also have a version where you have a bunch of mirrors that make up the striping with parity. So I just want to let you know they all exist, but these are the 3 main that you really need to understand in order to really understand how RAID works. Now, the next thing that I want to talk to you about is something called caching engines, and I've already talked to you in another lesson about a type of caching engine, and that would be a proxy server, right? If you remember the proxy server lesson, you will recall that I mentioned that part of what a proxy server does is when a client makes a request for a website, before it passes that request back to the client, it caches it so that if another client was to ask for the same website, the proxy server could go ahead and just hand them the website without ever having to send that information out to the internet. So this is how we help to make our internet bandwidth perform better. And then there is something else here that you need to be familiar with. It is CARP, which stands for the Cache Array Routing Protocol. And this is what allows us to basically have an array of proxy servers, basically. Okay? In Microsoft world, you can have multiple ISA servers, which are ISA, and I'm not going to go into the whole detail on that, but that's what their more recent proxy servers are referred to as. Or more currently, they're now called TMGs, or Threat Management Gateways. These are all a form of proxy server in Microsoft land, and the Cache Array Routing Protocol is what allows you to have an array of these servers. So it's almost like a form of load balancing and fault tolerance all built into our proxy servers, where various clients will go to the specific proxy server that is most available to them, depending on where they're located and what the load is. And so that brings us to the end of another lesson where we learned all about network performance and optimization. So you should now know how to go out there and keep your networks up and running well. And that's all I have for you. So I'll see you in the next lesson.